Hey guys, let's pause for a moment of science and talk about inertia. I want to do a demonstration for you today that I think gives you a little deeper understanding about inertia. Of course, remember, inertia is how we explain Newton's first law of motion. Now, you may be familiar with the trick that magicians do where they have a full table setting and they take the tablecloth and they snatch it very quickly, and the tablecloth pulls out from under the dishes and the place setting stays in place. And that may feel like a magic trick to you, but it's actually science. It is inertia. And so I'm going to simulate that activity, and instead of using a table and a place setting and a tablecloth, I'm going to amp it up a little bit, make it a little more fun, and I'm going to use, I have a jar that has a wide mouth on it. You can use a carafe or any kind of taller container. I have water in it. I have one egg, and it's a real egg. It is not hard-boiled. It's fresh from the refrigerator. I have a toilet paper roll, and if you're very adventurous, you can even use a paper towel roll. And I have a lid. Typically, when I do this experiment with my kids at school, I use a pie pan, but I didn't have any here at home, and so I just took a Pyrex dish type plastic lid, and that will be my table. So basically, I have my container of water. This is my tabletop. These are my very, very delicate dishes, my very delicate place setting. Now, the goal is to make sure, good thing I checked this, that everything is lined up even. In inertia, everything has the tendency to keep doing what it's already doing. What it's doing is staying still, and it wants to keep staying still until it gets some type of outside force. Now, the goal is to give the lid a nice force, so much so and so quickly that it doesn't affect the other objects. So basically, what gets the force gets the motion. Okay? So what I'm going to do is I'm going to count to 3, and I'm going to, as straight as I can, the lid, and I want you to watch what happens to the egg. All right? 1, 2, 3. Yeah! All right, that was awesome, right? Now let me explain what happened. Yes, the egg did move, but that's because gravity pulled it down. Now, I'm really good at science, but I cannot defy gravity. So that is one force that I can't go against. But I gave the lid enough force that it slid right out, and then only gravity affected the object. So it pulled the egg and the toilet paper roll down into the water. The reason why I keep water in the container is to try my best to save my egg, and let's see if I did. Breakfast! combine all the way. I'm not going to do that. I just want to open it a little bit. Enough to get it in.
Wait, you put the... Okay.
Fold, fold, fold.
Oh my God!
Hey guys, this is my son Drew. Say hi, Drew.
Heyo.
Drew's going to help us pause for a moment of science. So what we're going to do is Drew and I are going to simulate the question that I have for you, which is imagine if you had a kindergartner and a fifth grader both running towards one another and they collide in the hall, what that would look like. Now remember, we're talking about force and motion. We're talking about Newton's second law, which is force equals mass times acceleration. So mass and acceleration. So as you can see, Drew and I,
She's a kindergartner.
I'm a kindergartner, Drew is a fifth grader. We have different mass. All right, we are going to run towards one another. Actually, just to stay in the frame of the camera, I'm going to run towards Drew. I'm the kindergartner. Drew is the fifth grader. We're going to show you what that looks like. All right, Drew, stay right there. All right, here we go. Now, on the first one, I'm going to have a small amount of acceleration, which is really easy for me because I can run slow better than anybody. So here we go. Small amount of acceleration.
PSA, don't try this at home.
Right,
We're what you call experts.
All right, here we go. Ready? Okay, that was a small amount of acceleration. Now I'm going to show you what it looks like with a large amount of acceleration. Stay still. I'm okay.
This is why we said don't try this at home.